Hi, everybody. Can you hear me? I'm David Louvton from Salesforce.
Hi, I am Amool from Salesforce. I'm a lead developer at Salesforce.
And we're from the automation infrastructure team at Salesforce. We're responsible for basically building a shared infrastructure so everybody can run their tests and get results as fast as possible. So I think you all know Salesforce. But I have a question for you. How many of you really love Selenium? Like, really feel that it's working so well for hundreds of tests and also for thousands and 10,000s of tests? Well, oh, I see 2 hands here. That's pretty good. That's better than I thought. So let me tell you, we hated Selenium at Salesforce, at least when I joined Salesforce like a year and a half ago. We really hated it, but I think that we learned how to work with it. And what this talk is about basically really show you how you can learn from our mistakes, save years from your lives, save like $5.3 billion of your company budget. Just kidding, right? And yeah, learn from our experience. So this is the talk. So first, I think the one principle that guides the way we do automation at Salesforce is we want fast feedback. The minute developers or QEs or even machines, check in code, we want to have the fastest possible feedback. So we don't have like crappy code lines, so we don't build up a bad code. So if you put in a change, we want to give you test results. But we want to give targeted test results. We don't want to bomb the whole organization with emails and with useless dashboards. We want to have the person that broke the build or broke a certain functionality to know about it, and then revert the change. And that guides everything we do. And I think when you look at this slide, you'll probably be astonished. I don't know how many of you have this type of scale. We run more than 13 million test executions every single day. We do have quite a few code lines, and most of these test execution will happen in the main line because that's when there's most of the changes go. But of course, we do release patches and so forth, so these code lines have to be tested as well. And since we're at the Selenium conference, out of this massive scale, we also have quite a bit of a scale for Selenium. We run 1 million Selenium tests every day in 3 code lines. And to do that, of course, that requires tons of infrastructure, tons of hours. That slide shows you that how many machines we actually run. We use thousands of machines, thousands of VMs to run this infrastructure. Now, sure, a lot of you use Jenkins, Hudson, all this good stuff, and we have our kind of equivalent, which is internally coined Autotest, and this is basically a test job that runs automatically, that is being triggered with a check-in from our source control system Perforce, and with every check-in, an Autotest will be triggered and run thousands of tests. Now, the magic that happens is that this particular Autotest will find out if there are failures, and there are always failures, who to assign them to, right? And so forth. That I think is really important. Now, since we do have such a massive scale, it's really important to have a good distribution of the tests. So what we do here we you can add as many tests as you want to an Autotest. Say, Selenium Firefox on the main code line. You can add as many tests as possible. What we do is we'll bucket the test automatically into subruns. So if the organization decided that this particular Autotest is very important and it needs to have a certain SLA, then it translates to having more subruns. Now, in every subrun, which is basically a parallel track, we'll install the test bed, we'll install the app, we'll also install a piece of our software to manage the test runs. And inside this parallel track, inside this subrun, we'll also have multiple threads. So we can execute multiple Selenium tests at the same time. We'll also have more threads for setuping test data and tearing them down. Now, what's unique about the way we do things, because everything is being triggered by check-ins, we'll have basically, we're not going to have a consistent level of execution throughout the year, throughout the week. Sometimes, of course, weekends will be slower, but just the week before we do a feature freeze, that check-ins will go through the roof, and we'll probably need 20, 30 more times more capacity and more testing, because that's what the organization is requiring. So basically here you see a correlation between the number of check-ins on the left and the number of executions, right? And this thing varies a lot. So when you look at it, you would imagine that it's pretty hard to model our capacity and really predict when and where all the hardware, all the computing power will be needed. And of course, we want to be as frugal as possible, not just have all this capacity lying around. We want to make sure that we utilize it as best as possible. Or in other words, what we need is an elastic infrastructure, right? An infrastructure that could adjust to the number of code changes, to the number of test beds, new browsers, right? We want to scale onto different clouds. If EC2 is cheaper than VMware or OpenStack, I think Amool will talk about it some more, then we want to be able to be elastic and adjust and have as efficient utilization as possible. And I think I touched on the third point before. It's very important to prioritize our auto builds, right? The important auto builds, you give them more capacity, you give them more subruns, you get faster SLAs, right? It's as simple as that. Well, if only it was simple, but if, it used to be a manual process. By the way, feel free to ask questions if you have. I think we're going to have a few minutes at the end for questions, but all right. So here are some numbers, some more numbers about our Selenium infrastructures. First, we have 75,000. I just counted it last week. 75,000 Selenium tests or Selenium methods. Is there anybody here in the room where they have more tests than that? Just wondering. Okay. How many of you have more than 10,000 tests? Oh, interesting. And of course, these tests run multiple times a day, and they run on various browsers and so forth. That's 10% of our test inventory, which I think is still probably too much. It would be great if it was like 1% of our test inventory, I think. And that's a goal we're working on. Go ahead. What are all these written in? What are all these? What language? Java. Yeah, they're all Java. We have 52 Selenium auto builds, right? And you know, based on multiple code lines, multiple browsers, and the priority of them. You know, we bucket our tests into like basic tests, extended tests, and full. We have up to 70 parallel subruns for certain auto tests. That's a lot of hardware. Now, I think that the real magic is we have a system that we build that will automatically create, assign, close, and reopen bugs for test failures and flaky tests. And that's very important because what it does, it basically moves the burden of you know, handling these massive test results and failures from a few, you know, automation folks to the entire organization. You know, when a test fail, it's not you know, the test writer problem. It's somebody else's problem, and that actually is very effective. So another awesome algorithm that we have, just a moment, is about detecting flakiness. So what we do is, if we see that test, you know, historically worked fine and then, you know, fail and then pass again, we have the ability to tag them as flappers, and then we ran them again to actually make sure that doesn't mask any problems. And we still file a bug for a particular person, this time to the test writer. Go ahead, go fix your test because it's kind of it flaps. We don't want to you know, pollute the entire test inventory. Go ahead.
Back to point one. What are you using for a defect tracking tool?
So we use basically our own tracking tool. It's based on Salesforce stack. And it's highly customizable. I think it's probably the tracking tool with the most features I've ever seen. It works pretty well for us. Another question?
Yeah, I have a question. So I'm curious to know about how you figure out flaky tests. We have more than 20,000 tests, and I think that is one of the
So I will talk more about it later in the slide, but basically we have an interesting algorithm. So just in simple terms, we do a lot of rerunning of the test. If we have some mechanism to understand if this particular test is flaky or not, and when that happens during a particular run, we try to rerun it again and come up with the statistics what the previous runs, how many times it is flapping. I will talk more about it, and that's one of the most important reasons we are giving this talk, because that's how our infrastructure has changed, just to avoid that problem, because we know flaky test is costly to run. Every time a flapper happens, we call them flapper. Every time a flapper happens, we rerun them, and every time a rerun is happening, it's a cost for us. So I will talk more about it later in the.
All right, and here's I think probably a very good advice for all of you is the second bullet that I have here. I think that's working very well, at Salesforce. It's a good thing to assign, hundreds of tests and thousands of tests to people. Who cares, right? So what? I have 100 tests, but I also have, feature to release. The hammer that we use is actually a process that we enacted where we actually lock the line when there are too many failures. So if, for example, we assign failures, and then a week before we release, there are too many failures in that particular area, we'll lock the line. And now, developers and QEs and everybody will not be able to release or to push down features. They have to fix their tests. That's working very well for us. And we have an automatic mechanism to lock the line for certain teams. So basically we do a per-force lock for certain people, certain teams. And that's how we maintain a very high quality of the code. And of course, a lot of people bitching about it and hate us for that, But I think it's working very well, and we got the management support for that. We also have code coverage, Autotest, not only for unit tests and functional tests like other places. We also run them with Selenium tests in order to ensure high coverage and reduce duplication. Now, this whole thing, this is how it used to work probably up until a year and a half ago. We had a static infrastructure. In a static infrastructure, we had thousands of VM sitting in a static pool. So we provisioned them once, right? They all have static IPs, and then subruns that we provision dynamically will go and grab these IPs from these VMs from the pool. So for every subrun, it will have its own VMs. And just a little bit to drill into that. I mean, to a lot of people, that will look a lot like Selenium Grid. So we basically configured 8 flavors of pools, 8 flavors of VMs. One with a combination of IE6 and other browsers, one with IE7 and other browser, and so forth, right? When we create a test bed, which is a subrun, right? It will go grab a few VMs, right? And now once it has a VM, it will connect via SSH, change a few parameters, right? So it's able to connect back to the app, to the test beds, such as the app URL, right? And then, the VM will basically sync up the code, sync up the latest Selenium proxy that it needs, will get installed locally, and then after a cleanup and a restart, you'll have a VM with Selenium that can be used. So that's how we use that. Now we have a piece of software, the test runner that sits there on the Linux box with the app that will run tests in multiple threads. So that's how our static pool, a static grid worked. About a minute or so, a minute to 2 minutes. Now, as you can imagine, this had tons of issues. Really, it was a nightmare. First and foremost, we just noticed that flakiness or flappiness, that happened a lot. I'm sure a lot of you struggle with that as well. And it's hard to really understand the root cause of it, and that was very painful just to understand what's going on. It works and then doesn't work, but we just noticed, we assume that that's the cost of doing business, so we assigned more capacity to doing all these reruns, and we came up with quite a few measurements and quite a few ways to deal with that. Another issue is just VMs kind of degrade over time. You could do all the restarts in the world, but VMs became had all these mysterious problems. It could be IP conflicts. Why the hell would you get an IP conflicts when you assign an IP, statically? Or memory buildup was a major problem, and so forth. Another thing that we noticed was a pretty low and costly utilization. Because all these VMs were statically assigned and were powered and running all the time. If you, for example, had an IE6 VM, right? And at this point, no test wanted IE6, right? This 6 will sit idle, and that's a pretty big problem, as you will see in the next slide. And you asked how long did it take to restart and clean up and all this. A 2 minutes per VM sounds like not a lot of time, but it adds up. So that was certainly a problem. Yeah. It will be available after this. Yeah, not only that, we actually had a team, quite a few full-time employees that their only job, well, not their only job, but they had to actually maintain all these VMs, right? We had people that had to actually troubleshoot, update patches on these VMs, upgrade browsers, you know, do all these admin cases. That's a lot of money, you know, if you just talk even about 2 or 3 full-time employees. That's what our static pool required. And the last thing is the elasticity. As I said before, we want the ability to be elastic, to burst when we have feature freeze, to burst onto different clouds and so forth. And our static pool did not give that task. We thought about using Selenium Grid and Selenium and Amool will talk about that. I talked about utilization, so I just thought I'll throw in a graph to explain the whole story about utilization. So in that graph, we have roughly 1,200 VMs at that point. We had 1,200 VMs. As you can see, at any point in time, we're not even getting close to utilizing 1,200 VMs. The average utilization is about 50%. Here you go, a time sink and a money sink in front of you. So that was a major, and probably also a good driver for justification when we wanted to kind of move away from a static grid into a dynamic grid. And that's where Amool is going to talk about our Salesforce grid.
So we all love writing Selenium VMs, Selenium test, but do we running them continuously? I think most of them have their own issues. And to the worst, like maybe most of you at least have set timeouts on your Selenium test at least 5 times. Might added some more timeouts because it's just flapping. Or in the worst, you must have removed the test from the inventory, like stop running this test because I know this will fail due to some timeout regions. We had all that problem in all of our infrastructure. So we developed a solution which would be good for our use case. And what was the best possible solution out there? It was Selenium Grid. So what we did was we tried to prototype Selenium Grid inside our own infrastructure. And we tried to do something on this line. So this is how our infrastructure looked after we had a Selenium Grid. So as David explained, for every code check-in in our system, we had multiple Autotests. That is a collection of tests we are running. They all are running in different priorities. They all have different SLAs, and we have to fulfill them. Second, for every Autotest is highly distributed. It's highly distributed as in we can distribute a work on an Autotest to maximum 70 subruns running in parallel just to give results and feedback faster. And every subrun is again highly parallelized. Parallelized as in we can run n number of threads, and that is all configurable, and everything is configurable. So when a developer does a check-in, he can decide, or at least somebody in the system can decide how I want to parallelize it, how many subruns I want to run in parallel, how many threads I want to run on this. And with this kind of configuration available with us, Static VMs and Selenium Grid has their own kind of issues. So in this particular system, you'll see the only thing different between what David showed you earlier and what we have here is Selenium Grid sitting between all of our app VMs and all of our static capacity. So what you're seeing here is all of our tests are talking to this single Selenium Grid, and which is deciding which particular RC or WebDriver I'll choose for the test you want to run. And this is happening across 3 code lines, and this is happening across 75K distinct tests. All of the tests have different behaviors. None of our tests are doing same kind of work. We don't want to run tests which are duplicated in nature. So they all are doing different things. So those Selenium Grid gives us some advantages. We had some share of issues with Selenium Grid. So did we choose Selenium Grid? No, not. Why didn't we choose Selenium Grid? because first, it was not dynamic. Again, we had this all static VMs sitting behind Selenium Grid doing a specific kind of workload. For example, we will have a few 10% of capacity just doing IE6, 20% of capacity just doing IE7, and rest all will be doing Google Chrome. And we want all of this to be dynamic. Why we want to be dynamic? Because sometime a release is just happening for Google Chrome. And at that point, we want to run all of our Google Chrome tests. We don't want to use IE6. So Selenium Grid was not dynamic for us. Did it scale? Yeah, Selenium Grid comes built into EC2. But did it scale across other clouds we want to use? Did it scale across VMware we wanted to use? Did it scale across OpenStack? No, it didn't come inbuilt inside it. So we had to write something for it. So did it have high utilization? No, because we still had this static capacity sitting behind, which is idle sometime and which is on its max peak sometimes. So we didn't have a huge amount of utilization. And most importantly, maintenance. Maintenance cost of all of these VMs is huge. As David explained, that we had few guys just maintaining this VM, upgrading Firefox, upgrading Google Chrome, upgrading RC, applying patches. Though it can all be automated, but it has Windows VMs are not that great to be automation. At least that's what we have seen. And then, as somebody said, flappers, or as you might call as flaky tests, we call them flappers. Flappers are the biggest problem. Selenium Grid gives us the way to flash a VM, as in Selenium Grid will decide for you when I want to flash this VM or restart this VM and bring it back into the system. But how do we decide that baseline? How do we know that I want to start this this particular VM? How do I know that is 8 RCs running on this VM is good, or more than 8 is good? Considering they all have different use cases, they all have different tests running on them. So flashing, though Selenium Grid provides us a way to do a flashing, but it was really hard statistically to restart them. And then to configure. One of the biggest pain points we had with Selenium Grid was all of this our Selenium capacity was hidden behind Grid. Until the point a test starts running, we don't know what particular VM we will be on. And when in that particular scenario, if we want to do something with VM, we want to set up some proxy on the VM, we want to move a particular set of traffic to a particular different app VM or particular different org or Salesforce setup, it was really hard for us. And that's just one use case. So all of this capacity hidden behind Grid, we don't know where we'll be running or which particular capacity we'll be using at the end of the day. So configuration, it was really difficult. So what we did, so we developed our own solution, and how we did it, we chose the best thing we know, Salesforce knows. We moved all of our capacity to the cloud. Everything was in the cloud, no static capacity, everything was dynamic. And we call it Salesforce Dynamic Grid. What you are seeing here is we are now provisioning all of our Windows VM capacity at the runtime dynamically inside any cloud of our choice. Right now we are supporting, and we are using JClouds for it. JClouds is an open source API which allows you to provision VMs across any cloud of your choice. We have capacity inside VMware, which is historically our biggest capacity. Then we have capacity on OpenStack, and we can even burst into EC2 or any other cloud of our choice. So we developed a solution which can scale with the demand of organization, number of developers, a number of QAs checking in code, number of code lines, number of products in the system. We wanted a solution which is future-proof with Salesforce growth. So what exactly is happening here? What exactly we did? So for every Autotest in the system, we set up complete Salesforce app and DB from ground up. Every test gets its own unique identical environment. And why identical environments are important? Because of flappers. It's really hard to predict why a flapper happened in the system. So we have identical test beds set up, and all those identical test beds get identical Selenium VMs or Selenium capacity. And they have their own benefits. I will talk about why identical test beds and identical Selenium VMs are important for us. So for every source code check-in, we enqueue Autotest jobs, and for every test job, we pick up a configuration defining what kind of app VM it needs, what kind of Selenium VM it needs, and then we we provision that particular, that set of VMs in cloud of our choice. When I say cloud of our choice, means the cloud which gives you best benefits, which is cheaper for us. If we have capacity in EC2 and we have spot instances in EC2, we will do it in EC2. But if you have capacity internally, our own data center, we will do it there. So that's the solution we wanted. We wanted highly scalable solution, considering we have huge number of Selenium VMs, Selenium test. So what does Salesforce Dynamic Grid give us? Salesforce Dynamic Grid gave us support for multiple browser and OS combination. We can run. Sometimes we want i6. You might be surprised why we are using i6, because some of our customers are doing i6. They are still working on Windows XP, and we want to do some kind of testing on that. Some of our customers are on the latest browsers, and they are on different versions of same browsers. Some will be on older Firefox, newer Firefox, or some will be on the latest Firefox. And when you are in when you have such customers who are on different environment, we need a way to run our tests across all of our environments. What this grid gave us? This gave us multiple combination of OS and browsers. And the way we have written our code is we can configure once and deploy it in multiple locations. We will configure a VM template once, and we can deploy it in OpenStack. We can deploy it in VMware. We can deploy it in EC2. So Salesforce Dynamic Grid gave us a way to write once and reuse multiple times. Another reason it was very important for us was better resource allocations. Though Selenium is 10% of our capacity, but rest 90% capacity is F-test or other kind of testing we want to do. In those scenarios, we want to utilize our hardware efficiently. So our utilization was very high. We never had VMs. Which are doing nothing. Yes?
How do you deal with stuff going down in the cloud, the VMs not being available?
VMs not being available, or we don't have capacity. That's what the question is. So the question is how we are dealing with VMs going down, or if we don't have capacity. So the way we are dealing it is we are bursting it to different clouds. So that's why we needed a solution which can work on different clouds. So if we don't have capacity in OpenStack, and if we don't have capacity in VMware, which is inside our data center, we move to EC2. That's what we call it, a burst capacity. So we have some capacity reserved in EC2, which if we don't have capacity, or we know that we don't have any VMs, and we are on a particular day where all the developers out in the system are doing a code check-ins, we move to EC2, and that's where we get capacity. And open clouds provide more capacity.
How do you handle the launching time of these boxes and making sure that they're clean? Because obviously the startup time of a lot of these VMs can vary, especially if you're trying to launch these boxes in the cloud.
Okay, so the question is how do we control the launching times? And because start times in different cloud can be different. So our main goal or our main mission in Salesforce is to provide feedback in minimum possible time frame. And when we are talking about that, it means we want to keep our wall clock time similar wherever we are running. We want to give results in 1 hour wherever we are running. So what we do is we have some interesting algorithms using which we can reserve some capacity. We can predict where exactly a check-in will be going in. So it's some sort of prediction, as in we have something called as pre-check-in. We do some kind of testing before a code is actually checked in, which gives us idea what kind of capacity we'll be needing and where we'll be needing. We use that information to predict where we want to reserve our capacity. That's one way we do it. Yeah, go ahead, David.
So, but really the main mechanism is to find out the lower band, what's the minimum capacity that we will need in the morning, and then bring it up so it's available. So and then once they are being used, you get more ideas on how much more capacity you will need throughout the day, and then you start kicking them off on demand. Moreover, at least with VMware, it's not a problem at all. We are able to provision in about 15 to 30 seconds, so that's not a problem at all. With OpenStack and EC2, yeah, it's a little bit
tricky. 5 minutes, okay. So I'm gonna do my presentation, and then I'll go for Q&A because I just have 5 more minutes left here. So another reasons why Salesforce Dynamic Grid was important for us was dynamic first was dynamic, and second was deterministic test environments. All of our test beds were completely identical. And when you give identical test beds, a developer can go in later in the time and reproduce the problem. That's where Flapper is very important for us. Because if you don't give the identical test environments, we might be using a different environment when the test happened, and when developer needs it, he might be getting a different, when he's triaging a problem, he might see, oh, I cannot reproduce it because that's not the same environment. I don't have the same load as when you exactly run the test. So all the dynamicness is just to give developers identical environments. And when in those scenarios, they can reproduce problems much faster. Second reason why we need identical environment is, if we know that if a developer realizes that flappers are happening too often, he can say and suggest us that, you know what, this particular VM, you're running 10 threads, and the amount of memory or amount of CPU you have is less. So we can dynamically adjust the size of VMs. We can actually go ahead, a developer can say us, this particular test needs more a machine with a high memory or high CPU. We can provide that. So we can adjust the size of VMs in the runtime. Okay, so I will just run through this fast. So elasticity, high utilization, scalability, and disaster recovery. I will go and touch on disaster recovery, why it is very important for us. Salesforce has a high trust goals. We have customers who are paying customers, and we want to keep our trust as high as possible. And a disaster scenario, or scenario when a particular data center is burned down, we have ways to do e-releases in a particular different data center. And that's why cloud is very important for us. We can do testing in some other clouds, while some of our data centers have meltdown. So disaster recovery is very important for us, just to keep our trust goals very high and do e-releases, even when things are not good in data center. So how does the whole picture look like? This is something similar to what I showed you earlier, but here, everything is in the cloud. Everything is in the cloud. So a check-in comes in, we read the configuration, we deploy the VM configuration of VM size, number of VMs, and amount of capacity we need. And everything happens in the runtime in the cloud. Another important thing which I want to highlight here is number of threads we run into VMs, and all of these threads are running serially at test classes. They all get their own set of Selenium VMs. So as in, we might be having 8 threads running inside a VM, and they all will get their own Selenium VMs. And each test would uniquely talk to a different Selenium VM here. And this is, again, configurable. We can go from 1 thread to n number of threads. So this is my last slide. So Selenium worked for us, and I think you all should love Selenium. It is a very important tool to do user interface testing. It can improve productivity a lot in the organization. And third and importantly, you don't need a lot of money to do this testing. You can do testing in a highly efficient manner and at a low cost. And you should, everybody should go and boost the trust in the company, or the customer should have high trust on your value, high trust on the product you're building. So I think Selenium is the best way to do that. So I think that's the end of our presentation. If you guys have any questions, go for it.
Going back to the locking down code check-ins, is that a manual lock? So someone in the automation department goes, no, you can't check in, or is it automated?
So we have both mechanisms available. So the automatic lockup works by basically detecting that a certain team is under threshold, and then we basically we create. Oh, I have a feeling that people heard me anyway. And we detect this condition, and then we set a lock in Perforce. We also have a role in our company that is called a build master. And he's a person that makes sure that we can release given all the test results, and he has the ability to lock the line manually for larger groups, etc. We can probably take one more question.
So we don't have exactly something similar to what you said. We definitely have way on we definitely have way to measure how many regressions are happening, average number of or median number of regression happening per code check-in. That's one way we use, and then we have something called as regression measuring on the 3 code lines we have, like number of regression happening in main or versus stage versus prod. That keeps us. That allows us to keep our trust high, because we don't want a lot of regression happening in our patch environments or prod environments. So we do cumulative measuring, not exactly on a unique check-in way. Probably that will be a good way to do it, but right now we are not doing it. So one last question and we'll be done.
How to know which pieces of your infrastructure are open source?
Right now, I don't think so. We have anything open source as of now, right?
We haven't open sourced a lot, but Selenium that we use is pretty much Selenium out of the box with what we call a translation layer. I'm not going to go into that. We might have a lightning talk about it. We have JClouds, basically to abstract the calls from our provisioner to the different clouds. And everything else is pretty much homegrown and not open source yet.
But the dynamic tools we use for provisioning VMs, we do participate a lot in open source, doing check-ins into JCloud. So if you go into JCloud GitHub, you will be seeing a lot of check-ins from Salesforce developers in that area.
All right, thanks everybody. And come see us if you have any questions. We'll be around here for 2 more days, right?